three things which I think there's a huge development in espresso happening now, and I think this is the machines, the technology behind the machines, the tools that we use to prepare espresso, and then the last one is trying to tinker with extraction and some things. What is going on with the extraction of espresso? And just to start, it's already a question which is kind of today becoming more and more blurred. If you ask somebody 20 years ago what is espresso, would have been quite a clear answer. But today, this definition is going more and more, it's becoming more and more vague because of so many different brewing techniques and ideas of what is espresso. Just to mention, for example, some people today brew espresso without a crema. So that's already something that was unacceptable 10 years ago, but today some people accept this as a super light roast, a very long pulled shot of espresso that doesn't have crema. So of course, there's the traditional definition. I took this just to have something here from my some of my posts, but because I found some of the definitions which are quite interesting for espresso that are not so well defined when we talk about espresso, like what it is. And Illy defines quite in a very vague way espresso that is poured into a heavy porcelain cup, just over 50 milliliters. That's probably quite a lot for today's standards, but back in the day, 20 years ago, that was very much standard, or still is for Italian espresso. Then, and then the crucial part is a thick layer of tiny bubbles, so the crema, the foam. There's also a bit less from Petrarco, the definition. Espresso must be a small volume beverage that is more concentrated than usual. So you see that's from the books in the literature where you read a bit undefined definitions, which is good for us because this means we can have quite a free way of what we think espresso is and can brew it in many different ways and still say, oh, that's an espresso. Yes, but still in this traditional Italian way of defining espresso, this composite nature of foam and liquid combined together in one beverage that is important as a part of espresso. Although, like I said today, some people make espresso without crema and they consider this still as an espresso. If you go more into technical definitions of espresso, the espresso beverage is something that can be defined by some sort of metrics of physical and chemical properties of the brew, such as viscosity. So the espresso is thick beverage. It has quite a high viscosity. So this means that we have a nice full mouthfeel when we drink it. We have a certain concentration. Again, this is from traditional Italian espresso from Illy. We are here in 20 to 60 grams per liter. Or maybe if you're more familiar with TDS, this would be 2 to 6% TDS, which is quite low compared to what we're drinking here in the festival, where most espresso is around 10% concentration. We have fat in espresso, so lipids. Caffeine we extract, we can define how much we have. And then we define espresso also on how much coffee we used. Again, this is traditional Italian definition, one portion, 6.5 gram. I just had one here, which was a double shot, but 23 grams. So 11.5 per gram per one. So nearly double as this. So you see already these definitions. If you look into literature, what is espresso and how you brew it today can be very different. Then there's two other parameters that are important for espresso. We use pressure to extract, so we grind fine enough. And then we have this typical 9-bar extraction, which is kind of a gold standard number, still most often used, but it's also kind of not so fixed. We can have espresso. Some people extract espresso also with lower pressure, as we see later, pressure profiling, flow profiling, and so on. And then the outcome that we can measure with, often when we 2 espresso is we want to control the time, and 30 plus minus 5, very traditional. Today, it's again becoming more and more vague. What we call turbo shots. People extract espresso also in 10 seconds. So turbo would be less than 20, so like a really fast espresso extraction. But this parameters, 9 bar, 30 seconds, that's still the most popular way of drinking or preparing espresso. But it's it is changing, although quite slowly. And the other thing what is special for espresso is that we have a special machine to produce espresso. So when we have, for every coffee preparation, we have some sort of a tool to prepare coffee, and for most of the cases, the tools are relatively simple. But when we talk about espresso, we have a machine that has this function that we take a portion of coffee, we put it into the machine of ground coffee, we put it into the machine, and then the machine pumps the water at a controlled temperature, controlled flow, has to control the pressure when pressure is built up, and this has to dispense a certain volume of water in order to extract this espresso. So it has some sort of special function, and all these variables of the extraction, they need to be controlled by the machine. And with this, let's take a look at how the espresso machines, what kind of types of espresso machines we have, and how they control these variables. And I wanted to go a bit also into history to kind of present this development of espresso to better understand where we are today. So originally, espresso started as lever machines. So the lever machines push water, hot water, through a coffee bed. First, it was used by steam pressure. So the coffee was, the water was heated up to produce high pressure through steam, because to go to temperatures above 100 degrees Celsius, we need pressure to keep the water liquid. So this was original, but then this is not kind of real espresso, because when you have very high temperatures, you have very high extraction, and it's a bit it's hard to control. But then, like what we think the espresso today, it was first produced by what we call lever machines. So this is one of the first espresso machines. That's how they looked, and that was the machine that was able to reach 9-bar extraction and deliver hot water for long enough to dispense the volume of espresso in this 25 to 30 seconds time. And with this, it was possible to extract a good espresso, so a very tasty coffee. And these machines are still popular today. There's lever machines for home enthusiasts, really popular. There's many ones in the market, so it's not that this is part of history that it's not used today anymore. So this type of machine, as it was originally done, they still are around very much today. So here, the machine doesn't have a pump. So it was manually, through piston, with a lever, pushed to create the pressure to extract espresso. Then the next development of espresso came with Faema E61 and the group head design. So this here, the machine was using an electric pump to produce pressure of 9 bars. The group head was done such that there was a recirculation of water. The group was hot and was able to have stable temperature if the machine was not used to too much. So let's say every 2 to 3 minutes with the original design would be a good cycle time to make one espresso. Too short, you don't have the heat in the water. You go too long, the group head overheats, and then it's too hot. The water is too hot. And this is still a popular design today, this type of group head on many machines. So from the fundamental construction point of view, and but with many improvements. So they now work better, they're more stable, and so on. Then we continue with the next development This was so before we were in the 60s, now in the 70s. Another groundbreaking thing in espresso was the GS from La Marzocco, where thermally saturated group head is attached to the boiler. This was done to improve the stability, and there's also a separate steaming boiler to not disturb the heat of the brewing boiler when you're steaming milk. This is because when you steam milk, you actually need much more energy for the steam than when you're brewing coffee. So for the heat of the water, so when both work together, there will be disturbance in the system. So this was done to kind of improve the temperature stability of the water that is used in the machine. And this was all done kind of with pretty primitive mechanical control of the temperature of the water. And then there was kind of, in my view, a bit of a quiet period in espresso where not much happened. So at least what happened didn't stay on. So the machines were kind of very similar, just their looks changed, but fundamental functioning of the coffee machine was still pretty much the same as from the 70s up to 2000s. There was not really a big change in the design, how the machines worked. And then what happened the next, like a big change in the operation of the way how the espresso machines work, was to improve temperature control. This was done by using PID control. So PID stands for proportional integral derivative. So it's like it's a mathematical function with which you are improving fluctuations. So it's in a certain variable with better control through this algorithm. I found somewhere that actually this was used in the 1980s already on a machine, but it was kind of forgotten. Nobody knew about it and it was not popular. But then in the mid 2000s, actually it was home baristas who started to talk about this. Engineers, they would put this control system on a machine, that they would modify it and would greatly improve the temperature stability of a coffee machine. And then the manufacturers saw this and saw that there's really a need to integrate this system into the coffee machines. But this is not some sort of fancy system, as sometimes it's maybe portrayed in the coffee community. It's actually quite basic, and having this only in 2005 is very, very, very late, because it's not such a hard thing to implement. And this was like what I'm talking about now. So mid 2000s, the espresso development was the machines and the technology was mainly only on improving temperature stability of the water that was pumped out. So we're still talking about 9-bar extraction, no control of the extraction pressure, no control of the volume of the water. Everything's just done really, really simple, really kind of this electronic, but most of the things mechanical. And then because the development of espresso and the culture, that is now the specialty culture, started to put more and more demand onto better control of the extraction process and better, just to have more options in how we extract. There was kind of a drive to improve the extraction consistency. So first, how this was done the most simple way is by using pre-infusion. So pre-infusion is a part of extraction of espresso where we don't just start and pump to 9-bar. So we have a certain time at the start of the extraction where the pressure is limited to a certain much lower pressure. So let's say 3 bars typically, or 2 bars, or maybe even 1.5. Depends on the machine to machine, and some machines can also set this up to a given pressure. So we start to pump the water into the coffee with a certain flow, but then we don't push very hard through with 9-bar pressure when we have the resistance, but it kind of goes slow. The water goes slowly with a lower pressure through the coffee bed to kind of wet the coffee particles. And then this gives us better extraction consistency. Because if you imagine that we just push the water through with a force as much as we can at these 9 bars, there's a high likelihood that the water will flow on one side and not on the other side. And then we get first inefficient extraction, so we're not extracting efficiently, but also this what we call channeling, so inhomogeneous extraction causes that on one side we are not extracting, and on the other side we are over extracting, which usually brings to sour, acidic, and at the same time bitter espresso. So this kind of technology that I'm talking now had the more of a purpose not in stability of extraction, but in improving the flavor. So kind of at this time, around maybe 2010 to 2015, the development of the technology behind espresso was to improve the flavor. The driver was not only consistency and pulling a lot of shots, but really trying to go towards improved flavor. This could be done, of course, with the lever machines because they're manual, and the barista could manually see how the coffee is flowing and do more force or less force, and you can be this way controlled. But this was, in terms of commercial setting, very rarely done because it needs attention from barista. It's much easier to press a button. It's kind of it was not used much. It's a very niche today, a lever machine. And then one of the next development was to do full pressure profiling. So what I mean with this is that you don't have only first stage with a pre-infusion with the lower pressure during extraction, but then you go towards you can control whatever pressure you want throughout extraction. So La Marzocco did this with Strada EP. So EP stands for electronic paddle. So there was a control in the paddle where you can control how much pressure the machine gives. And it was possible to pre-record profiles and also to make a profile and record it and reproduce it. And the idea was to kind of put the lever machine functionality to control the pressure into a electronic pump driven machine. So this worked pretty well, but it comes with some problems because if you imagine you have a certain profile that you want to follow, a pressure, if you do it by a lever and you're a barista, you're looking at how the coffee is flowing. But this machine has no way of knowing how the coffee is flowing. It's just delivering a pressure. So when you are doing this and you want to reproduce and you didn't grind the coffee the same way, then if you're reproducing just the pressure, the flow, what is going out, can be completely different. So this works very well if you know that you have always exactly the same prepared puck, the bat of coffee. It can reproduce, but once you're slightly out, then you're getting extractions which are completely inconsistent. And then you have, of course, a lot of, if you have lower resistance, you do the same pressure, you get a lot of volume of the coffee. So your coffee will not be thick and concentrated, but will be very diluted. And with this comes the next trick that espresso machines pretty much today all use, is to have some sort of way to control the volume of the beverage. And this is mainly done by a flow meter. So flow meter is such a device where the water flows through this kind of wheel inside. It turns the wheel, it rotates, and there's a sensor which measures how many or how fast it's rotating, and it's calculating what is the flow rate of the water through the machine. And in this way, it can know how much it pumped through, and it can first stop the espresso on a given volume of pumped water to not, go by time and just extract with way too much water if there's kind of inconsistencies. And this brings then another way of controlling and improving the espresso extraction. Sometimes you hear this that this is a volumetric machine or a volumetric pump because it's measuring the volume of the water pumped, but in reality it only reads how much flow of the water is going through, so it's not measuring the volume. We'll see later what is a really pure volumetric technology, but this is kind of indirect, and it has advantages, disadvantages. The disadvantage is not you cannot follow very nice profiles. You can only use it very well to define an endpoint. But even this endpoint in volume, it depends plus minus on some things. For example, what is your volume of the space between your shower screen and the coffee bed, which needs to be filled? How much water the espresso, the coffee, the grounds for espresso soak up. So these are like things that can change. And if you only measure the volume of the water that you pumped in, you don't necessarily get out in your beverage always the same amount of espresso. So the next step from this is to control the volume of espresso in your cup by weighing it. So this is what we call Gravitech, or what was the first introduced in a Black Eagle machine, or gravimetric espresso brewing. So this is much more accurate, especially when you use low flow rates and long shots where flow meters are not so accurate. This is more accurate, and today also many machines. So from this 2015, the first one that was launched, many machines have this function. Like the one that is now at the Stobar, for example, has this function. So there's a scale integrated in this drip tray. Here you see this square. It's actually a scale, and it's weighing the amount of espresso beverage that is produced. So if you can say, oh, I want 40 grams of espresso in the cup, it gives you 40 grams of espresso in the cup, because it's measuring how much is the weight of the coffee in the cup. So this is really useful for like just to have a lot of consistency and not to bother with how it's flowing and what is now the end point, or is it plus minus few milliliters and so on. So it's giving you consistent result. Of course, there can be things that are problematic here, because it's a scale. If you hit it hard, your temper drops, your portafilter drops. It's possible to damage it, or to just, it maybe needs a recalibration, and you can be off if you damaged it. Initially, there were some problems with vibration. So if you hit the table or the bar too strong during the extraction, it might be that it kind of loses the control. But today, through tricks that the manufacturers do in how they treat the data, most of these problems are, I believe, now gone. Then it's this was like I'm going with types of espresso brewing around 2015 and towards 2020, and then around this time this machine became popular, which is the decent espresso. And what this machine did is that we were talking now about temperature, we were talking about pressure, we were talking about volume. Each of the machines that we had before had a bit of a slight improvement. They maybe controlled one, the other one was fixed, or vice versa. And then the idea of this machine was to be able to control everything in any kind of way imaginable. So you can make, has a tablet, you can draw, I want pressure profile like this, you can go up, down, whatever kind of profile you design. The idea is that you have full control over the extraction. So this was kind of the idea behind this, yes, to have the full control of the extraction and to produce coffees that are just different and unique, and to have a different approach to brewing. It's of course the question is, does this work, or is it better? That's a subjective thing sometimes. Sometimes you also think that, oh, this 9-bar espresso through so many years of development optimization must be somewhere close to extraction, to perfect extraction. But then also what is happening now in the last 10 years, that the roast profiles change differently. So the way how coffee is roasted is different. So this also then impacts how we should treat the extraction. But this machine is really only used by home barista community. It's not such a machine to put it into professional bar, because it's not meant to do this in a really controlled, stable way. So then there's ideas from other manufacturers to have this full capability of flow control and pressure control and temperature control, but it really was never launched. So the full capability of this kind of espresso the Duval espresso was launched in 2018. I mean, showed in 2018, but never really launched as a machine that can do meticulous. Is a machine that can do all these profiles in a very stable way, but it doesn't have a boiler. So it's a bit, again, tricky. It's again for home use only. This very recent development of a machine is this one. It's a Swiss machine, Unica Pro. So this one is a piston pump machine. So it's kind of a lever machine, but instead of a person controlling the lever, there's a motor that is pushing the piston. So here you have the characteristics of a lever machine, or you can also reproduce the characteristics of a regular espresso machine with a pump. So like typical 9-bar extraction. And this machine has also one thing that now it's very uncommon in espresso. So now most espresso machines have a boiler where the water is heated up. And then when you say I have hot water, you pump the water out. So this machine has no boiler. So the pump pumps cold water. It goes to a flow-through heater, first in the terms of a thermoblock. So this is kind of a spiral where the water goes through. It heats up to like about 80 degrees Celsius. And then in the group head, it heats this in 4 or 5 stages in small steps into your desired endpoint temperature. So this is like if you compare this to a GS3, so the La Marzocco machine, for home use, this uses like 1/20th, so like of the energy, of the electric energy. This is because there's nothing to heat up. It just heats up really just the water. So it's kind of latest development. If it's in espresso, it's kind of single group. It's somewhere in between the home prosumer equipment and professional. But I feel like this is maybe a technology where we would see espresso machines going in the next 5 years or so to implement this. So no boiler and piston pump to control both pressure profile and flow profile in any kind of way. The next part I want to talk about is what also is recently becoming very, very popular, is the use of espresso tools to improve brewing. Of course, the function of the espresso machine is to push water on the espresso bed. So there's things that help with this. There must be some sort of a shower screen which creates a shower of water on the top that then evenly distributes the water and then pushes into the water into the portafilter basket with where the coffee is. So that's important to distribute this water. So there's like development of different shower screen diffuser screws. So these things are always optimizing and improving this distribution of water. Recently, these high-end coffee, so sort of high-end espresso baskets emerged. So if I just quickly go back, so if you look at this, like a traditional, like a higher-end basket, VST basket for espresso, it's made out of a sheet of metal and punched through to get this shape. And this shape is like a bit, it's not a purely cylinder, it's a bit rounded. And the point of high-end baskets like this unifilter is that they are CNC machined and the holes are laser cut or drilled. And then we have a perfect cylinder shape of the basket. So then the coffee bed at the same diameter is lower because of this. And this brings us better extraction efficiency, but also there's downsides. The holes can clog with small particles. It's harder to get a good extraction because it's lower bet. So while in the numbers, maybe these things improve your espresso if you're into numbers and extraction, in the end the flavor is sometimes much more tricky to get to a good flavor. Talking about the flavor, I kind of went into this topic earlier when said about the homogeneity of the extraction. So if we want to improve the homogeneity of the extraction, we need to make the ground coffee in the portafilter as evenly distributed as possible. And now what became now really popular, especially during COVID, because of the rise of the home barista scene, because so many people are brewing coffee, or not only coffee but espresso at home. There's like really many tools that you can use to improve this distribution, and to kind of with the goal to improve the quality of the beverage. So this was one of the first that came out, OCD from Sasha Sestic, and he did use this in the World Championship, so that's why I think everybody who's in coffee knows this. The point of this machine is that it levels the top layer of the coffee before tamping it. But it does this, it levels the top layer, but that's not, for today, that's not enough. So there's tools which disturb the whole coffee to improve it, to improve the homogeneity. So one of those that really makes coffee homogeneous is a shaker devices, such as this, what is called the blind shaker. So you put the coffee into a container before you put it into portafilter. You shake it to really homogenize it, destroy the clumps, and then it goes to the portafilter, you tamp, and then you extract. And I use this at home and also at work when we do some studies. And these things really make a difference in terms of numbers. So if you want to have exactly the same extraction and you use some of these tools, it really makes a higher extraction yield. So you're extracting more, which brings you basically more out of coffee, which also in the end consequently brings more aroma into the cup. So it improves the flavor. Another device is these ones that use acupuncture needles, where with needles you go through the coffee bed. Sometimes you hear WDT method after a name. It's I think after a guy on some forum online. So wise distribution technique. Or today also some companies actually, because this is so popular, make some sort of weird tools that look interesting. There's like on the bottom left one with gears, where you rotate gears and these needles move, or the autocomp on the right, where you like rotate it like this to disturb all those the particles, to kind of with the ultimate idea to improve the homogeneity of espresso extraction. Then this is all about like things that where you impact extraction, the way how you extract, but then the whole other thing is also thinking about how you evaluate your extraction. So if you want to go into brewing espresso, well, of course sometimes you need to what you call dial in, change the grinding size, change the recipe, and so on, and then you taste coffee and you decide, oh, this one is now the best, that's the best coffee, how I want to drink it or how I want to serve it. Our taste is really the ultimate thing for evaluating espresso, but it's sometimes nice to have an instrument tell you a number, because the instrument doesn't get tired, it produces the same number over and over. But us, if you taste 5 espressos in a row, at least me, then after that I don't taste anything anymore. So many baristas use refractometers to control their extraction. A refractometer measures the TDS, or the concentration of the material that is dissolved in the brew. And with the measure of the concentration and the weight of the brew, we can determine the extraction percentage or extraction yield. So how much we extracted from the coffee. And we usually write this in percentage. To better give you an understanding of this process of calculation, so what basically happens is we have a a coffee. We have ground coffee, and with the extraction process, we add water to the coffee. So then the extraction happens in the machine. We end up with espresso brew, and we end up with some spent grounds. So the spent coffee grounds. So the spent coffee grounds stay wet. Typically, they end up with double the amount of water than the weight of the grounds. And we have our brew with a certain amount of water. So now we can calculate two parameters which tells us how strong we brewed. So these are what we call beverage ratio. So this is mass of the beverage of the brew divided by mass of the coffee we used for extraction. So this is typically done in espresso because you don't know how much water ended up left in the top of the spent coffee puck. The other thing is the brew ratio. This is typically used for filter coffee brewing, where you have a scale and you add water on the top, and you're measuring how much water you added on the top divided by the weight of the coffee you used for extraction. So these numbers tell us how strong we brewed. So typical for espresso is maybe 1 to 2. For a very nice strong espresso, if you go to 1 to 2.5, will be more diluted. If you go 1 to 3, even more diluted, and so on. And once we measure the TDS by refractometer, then we also calculate the extraction percentage. This is the percent of the material that we extracted from coffee into the beverage. So this is typically around 20%, and then depending on the brewing method and the recipe and so on, plus minus some 5%. So now what is actually happening during the extraction? So now we have kind of all those, we have the tools, we have the ways to control the espresso, we have ways to control the temperature, we can control the flow, we can control the pressure, the grind size and everything. And then we have a certain extraction. And we, with experience, we know that if you extract longer, you usually get more bitter espresso. If you extract shorter, so faster time, you're getting more acidic or sour espresso. And to understand this better from a chemical point of view, I have these charts. Perhaps I need this one to explain what is actually happening during the extraction. So we have, first one is here, the extraction yield, the black one. So we are here at 20%, and we extracted like everything up to 20%. Not everything that is in coffee, but relative to 20%. So we have a certain line that we go here, this black one. Now we can take a look at different components of coffee and see how those extract. And here we have acids in coffee, and what we see is the acids, this line here, these measurements, go higher up. So this means that we are extracting a bigger percentage of all the acids that we extract much faster. So in 10 seconds, we already extracted 80% of all the coffees that we extracted in 20 seconds. So it means that acids are extracted really fast. In a short extraction time, we are extracting already a lot of acids. So this turns our espresso sour if we have too short extraction time, because the acids are really fast extracted, but then other things are not extracted so fast. So we have like an overpowering flavor contribution from the acids. Then if we look at some other compounds, caffeine is slower. Then the total yield, chlorogenic acids, about the same as the total yield. But I'm talking about caffeine. So caffeine is it's water soluble, but it's extracting a bit slower. Some similar molecules to caffeine that are bitter are behaving the same way as caffeine. So what is happening here is that if you are extracting very fast, these compounds are extracted quite inefficiently. If you extract them longer than 20 seconds, when the acids, if you imagine this curve going on, it would not go much higher up. But if you imagine this curve going here, it will go up there. So these bitter compounds that are hard to extract, they're not so water soluble. When you extract very long time, you give them time to be extracted, and then you end up with coffee that is very bitter if you extract for a very long time. Of course, it has to be given that this coffee has these bitter compounds. If it doesn't have them, like a very light roast of high quality coffee, it might not get bitter. But if you have a medium roast which has bitter compounds and you do this, you will end up with a very, very bitter brew if you extract very long. Second part is the temperature impact. So now you can say we control by time or the way how we extract, but then also the temperature, which is a driver of the extraction, will also have an impact to how we control the flavor of our espresso. So this is typically espresso is brewed around 90 something degrees Celsius. So here we have some sensory data for espresso brewed at 90, 93 and 96 degrees Celsius. And we see that there's quite some differences in the sensory results, like how the espresso tastes. So we have bitterness. So bitterness is low when we have lower temperature, and it's higher if we have higher temperature. It's again what I told you earlier. You have bitter compounds that are hard to extract. So if you increase temperature, you will extract them faster, so you'll have them more in your cup. When you go with acidity, it's the opposite trend. So at lower temperature, you already extracted lots of acid. Now if you go to higher temperature, you do extract them more. But because these flavors, when we taste coffee, they work one against each other. If you have bitterness, more bitterness, it means that you're perceiving less acidity, because it's kind of a way how our perception works is that if we have a lot of one taste, it will overpower the other. So we have kind of going bitterness and acidity one against each other. What we see also here, body, that's interesting. So body is something about the thickness. The thickness improved by lower temperature, and this is likely due to perception. So maybe bitterness, again, it was unpleasant bitter, this espresso when brewed in high temperature. So then because of this, the panelists who tasted this also thought the body is also not so good, because there was an unpleasant, very bitter experience in the mouth. And this finish with this one. This graph where looking at how much we actually extract from total from coffee at same of those different temperatures. That's like a measured yield. So the TDS actually to 90, 93, 96, 90, 93, 96. When you extract coffee, in this case, it was around 80, 83% of total extractable material in coffee was extracted with this coffee. So actually going from 90 to 96 degrees Celsius, we were not significantly changing the amount that we extracted. So it's not that the temperature enabled us to extract way more from the coffee. It kind of disturbed the balance between different tastes, like the bitterness and the acidity, but we are not getting much more extracted just because of the temperature. So this we compared against long extraction, like 100%, and then we had here different ones. And that's for two brew ratios. You don't see much differences with the temperature. So it's really the temperature impacts the balance between bitterness and acidity in terms of flavor, but you're not increasing the TDS, you're not increasing the yield by the temperature. Yeah, so with this, these are some of my thoughts for today about how I see espresso brewing, how it changed, and some of the ways what I think about, or some of the things what I think about when I brew espresso, with how I approached brewing it. I always have these things that I talked about today in mind to think about when you're kind of defining your recipe or optimizing your recipe. Think of the things, tools approaches, profiles, and so on to try to change and improve. Thank you.
Hi, thank you for your lecture, and I would like to know your personal coffee making, how geeky your home espresso making, what kind of tools do you use, what's your approach to this?
So yeah, my personal approach is I kind of already said what I think are the best ways to do. So I have the Unica coffee machine at home. I mean, simple reason is when I first saw this machine and I saw the capabilities that you can do any kind of flow profile, any kind of pressure profile you want. You can have a machine ready in, I think it's less than a minute or so from starting it up. So it's like for home use, really nice machine to use. But I think in the end, machine purpose is to deliver the water. So it's kind of, it's nice to have a good machine, but in the end, it's just the purpose to deliver water with temperature to the coffee bed. So I think two other tools are really important. Yeah. So for my personal view, I really like shakers because the reason for this is, I think that's like one of the things, if you're into espresso and if you never used a shaker, I encourage to try one. And the reason is because when you grind coffee, you often don't grind the coffee particles the same way when you start grinding and when you end grinding. So you often, if you grind into portafilter, you end up with slightly different grind size on the bottom and on the top. And there's maybe slightly different clumps or slightly different compacting of coffee happening. And by a device that does shaking, you are kind of homogenizing all of this. And for me, this is really brings a good result to the extraction then, because the extraction then becomes more homogeneous.
Thank you.
Yeah. And of course, there's also a whole nother topic which we haven't covered today in espresso. That's the grinders, and the grinders are super important. But my goal for today was to go more into understanding the machines. But the grinder is a whole nother topic which is also extremely important. Objectively, probably even more important than the coffee machine for a good extraction.
Thank you.
I use only temper, yes. Like normally I would use only temper, but also some people also still use the WDT or the autocomp. Yeah. So I've seen not only used for home baristas, also more and more in coffee shops, baristas start to do these things for every espresso that they extract.
I have a question about espresso crema. I mean, can you have a good espresso made with good coffee and it has only a little crema? I mean, is crema as important on espresso, or does it make a difference?
This is, that's a really good question. I think it's a bit controversial. So some people say that to answer this question, the best is you have to try it on your own if you like it. And the best way to try this is that you prepare fresh espresso and then you take a spoon and you scrape the crema off so you don't have the crema, and then you compare espresso with crema and espresso without crema and taste them both together. So for me, the opinions are divided. I personally like the crema with espresso, but some people say, oh, if you taste the crema on its own, it doesn't taste good or it tastes really bad. So it kind of destroys the other part of coffee. But I feel like it's maybe what we're used to also, that there must be some sort of this crema flavor for the first few sips, and then you're going to the other part, which is nicer, and it kind of it's part of the experience maybe. But
Me-
if you're not, yeah, if you think the other way is better, it's really a subjective thing.
I mean, I ask it because can you if I have a good coffee and I brew espresso and it has a little crema, um, does it mean this that espresso is still made good? I mean, it's still good coffee if it doesn't have any crema on espresso.
It can be, yes.
I mean,
The-
good
the-
roasted coffee.
Yeah, the definition is what is good. That's kind of hard to define, right? The good is what you like it, or what the person who you brew it for likes. So if you like this very much, then that's good for you. So that's why I go into numbers, because numbers are not good and bad. There's a certain number, and you say this is lower extraction, this is higher extraction. You measure acids, you have more acids, less acids, and there it's clear, right? But in the end, if it's good or not, it's a matter of subjective decision. It's your brain telling you, oh, I really like this, it's good. Then it's good, you can't argue with this.
Okay, thank you.
Thank you so much.